Hello everyone, I hope you all can hear me. My name is Mariana and I'm from INESC and University of Minho, and I'm here to introduce you again to this initiative, which is a joint webinar series between the BigHPC project and the UT Austin Portugal Program. I wish to thank you for participating in this session. In this webinar, we'll welcome Bernardo and Miguel Viana from LIP. We'll talk about a deep dive on BigHPC platform delivery into HPC clusters. Bernardo is a software engineer at the Laboratório de Instrumentação e Física Experimental Partículas, also known as LIP in Portugal. Samuel graduated from Lisbon University with a degree in computer science and engineering and is finishing his master's dissertation. He's currently working on the BigHPC project and on the development of platforms that are focused on software and service quality assurance as a service, and is involved in several national and European projects, and is also an open source contributor for several years, supporting the community and free software. Miguel Viana is a Linux SysAdmin at LIP-Minho, graduated with a degree in industrial electronics engineering and is finishing a master's degree dissertation in embedded systems. Miguel is interested in areas such as high-performance computing, automation, containerization, and informatics security, currently mainly working on the BigHPC project. As I said before, my name is Mariana Miranda, and I'll be the moderator of this session. I would like to inform you that you can and should interact during this session. To do so, you can use the chat to share your questions. During the presentation, there are no discussion moments, but at the end of the webinar, we'll have some minutes to discuss all the questions and interact directly with you. I will monitoring the chat activity and ensure that all questions are dealt with by our speakers at the right time. So now we move to the presentation. So I'll stop sharing my screen and I'll kindly ask our speakers to share their screens. In order to kick things off, the screen is yours. Please start.
Okay, thank you, Mariana, for the introduction. Okay. I'll start to share my screen now. So just passing this first slide. So today we will talk about the BigHPC platform and our experience on the deployment and integration with HPC infrastructures. So mainly our target today is to understand the part of deployment and development of code and testing and validation. So just summarizing this presentation, in the first part, we will start to overview the BigHPC platform. Then we go through the development challenges that we faced during this work. Then we will show the value that come from we adopt the GitOps methodology for deployment and what we worth when using it. And the second step, there is also another very important point that is about the pilot for the BigHPC platform and how we are conducting the testing and preparing the validation for the final pilot. We are also focused in another detail, that is to put all teams together working with good practices and software quality approaches. So that is what is translated from the testing that we are here bringing to this project. And also, since this is many concepts and they bring many opportunities to put everyone working together, we will also talk afterwards in the solution. So about the development and operation automation. And in the end, we'll show what will be the next steps that we will do until the end of this project that will end on March. So this, to start showing what the BigHPC platform is. So this is the initial architecture of the platform that relies multiple components and services. Mainly they are the virtualization manager, the storage manager, and the monitoring backend. So they will integrate in the HPC facilities in their compute nodes and allowing to get better performance accessing the data and the storage nodes. And now in this work, we just start to retrieve the main components and understand how they can be integrated and tested and deployed in the end. So summarizing these main ideas, we have this kind of, sorry. So we have this kind of main components that we select here and try to just create a frame between what can be called as platform global services and those that are local applications. This is important for the integration tasks and the deployment facility that we are conducting. So this is just as a very brief summary. So in storage manager, for instance, we have the storage global controller and the storage local controller. On monitoring, we have Monica that just collects the logs and allows to do the visualization. And then we have Hector that goes along jobs and can collect logs from the machines and also from the job itself. And in the end, we have the virtualization manager that also integrates with the previous ones and provides the VM controller, the VM repository, and the VM executor. This is the same thing. So we have this kind of components already tailored to specific tasks that can be more local to HPC nodes or can be just centralized like we are showing here. So what we are trying to do, so looking to the development challenges, we are trying to apply a development methodology. This one is called DevOps and is based on agile methodology for development, so for software development. And so what we are trying here to connect. So we are trying to connect two different realities, the reality of a software developer and also the reality of system administrators and operators that work more directly with the infrastructures. So what this schematic shows is just like a kind of summary that tries to put everything in place altogether. So the difference between traditional methodologies that follow a kind of waterfall methodology, it just brings instead of just passing to development of software, then the analysis afterwards. Here you are seeing how we can just run everything at the same time, because this will bring additional value for achieving better releases and also achieve better code. So this means that we need to provide kind of interfaces that allows to provide the reporting and all the information that is required for everyone to be in place and understand what is required to do for every single release for this platform. So this is important because in the end, the big problem is about the cost. Okay, so about the cost is how can we enlarge this kind of softwares to real infrastructures and not placed there with bugs that can be very expensive. Very expensive because the cost of computing on this kind of infrastructures is high. So we will try to produce a kind of facility that provides all this kind of testing, this continuous testing that I showed in previous slide, and that and can favor in the end all the quality of the provided solution. I'm sorry, I hear you some. Okay, so I was think someone was not muted. Okay, thank you. So in the end, we are following all these methodologies and testing all together, so we can find the best and optimized point for testing and delivery, minimizing the cost, of course. Also, when we look to this, we have two different realities. So we have the test beds and you have the environments. So what we are doing here, so we are trying to in place the developers' environments within the infrastructure. So with the test beds that we prepared for each let's say, hardware representation that we need for each stage. Actually, we are trying also to define specific execution environments for the required test beds. And afterwards also try to gather all the requirements and use cases around applications that we need to manage. We also want to prepare the pilot to test the platform competence with all the collected use cases and applications when using HPC clusters. And we need also to collect the metrics and get the report from job submissions. So all of these will be also correlated with these environments and test beds. So how can this be, let's say, materialized? So in the first step on our development, we are trying to find solutions that allows to connect the development environments and the multiple scenarios that we define here with test beds. So we have the development test bed, we have the preview test bed, and after all these steps, we are ready for delivering the pilot, and that means that we can have the final validation. So mainly, we are centered on GitLab. We are trying to manage code over that platform, use all features related to software management and the project management over that platform, and also produce templates that I'll show in the next slides that allows to easy the task for the developers when just trying to receive the feedback for their code. So the testing and the metrics and everything that we can collect afterwards, and keep everything quicker in terms of quality and releases. Then there is another challenge that is related to security. So we also need to check if everything that we are doing and running, and not only security, but also, as I mentioned before, the cost of testing, because this also represents a cost. So, but on this regard, we are most looking to the part of security. So we want to find some kind of deployment methodology that allows to take users outside from infrastructure. And our solution that we are just presenting today focus on the GitOps methodology that allows to do that kind of isolation. So in all this procedure, the users never need to get direct access to infrastructure, and everything is automated from GitLab. So in the end, everything is validated, everything is tested, all scripts are in place, all tests are running, the security tests, every kind of testing. And in the end, code is deployed in a first testbed, that is the development testbed that is on a Kubernetes cluster. And later it will be deployed into the real infrastructure with the real services, as I explained before. So just summarizing, what is the GitOps profit? So the first one I can just mention here is that it allows to deploy the applications without thinking on the tools and everything that normally someone need to think about when they want to use some kind of infrastructure. So here, everything is abstracted in configurations and code that will be loaded automatically by an operator, let's go like this. This also provides a lighter learning curve since everything happens on Git. So if we think on developers side, they normally nowadays knows this kind of version control systems, and Git is one of the most popular. So afterwards, they only need to know about Git, and this is the main point when gathering all the requirements for software. And also the error recovery, because it is also easy to revert to a previous version using the Git history facility. So we can always get previous versions and try to recover from errors faster. There is also another point that is important, that is about credentials management. So in terms of credentials management, we only need to think that they only need to access the Git repository itself. So there is no need to access the infrastructure. And all the feedback will be collected on GitLab itself. There is also no need to give the developers the direct access to the deployment endpoints. So all that information can be presented outside those endpoints. So the access will be on specific endpoints that will show this kind of information. And there is also another important point that is about the description. So everything is being reported, and this just stored on Git. And this is not only code, it's all the code, but also all the reporting, all the objects, everything that you can think that can run around these kind of deployments and environments. There is also another important thing when we use this kind of methodologies, because they just bring the knowledge sharing when everybody can just place the messages on the commits and the things that they push to the repositories. Now talking on Git push between local and remote repositories, and also find examples how to set up new systems, because everything will be there. So everything it will be accessible easily from Git. Also the documentation, all the information. So everything will be easy searched and findable for everyone that wants to reproduce it. So we are talking about this kind of isolation between infrastructure and the developers facility that we are selecting GitLab in this context. And for that, we need to adopt a deployment strategy. Here, the deployment strategy that we adopt is the pool-based one in the GitOps kind of deployment strategies. This allows to do the required isolation. So there is an operator, let's go like this, that observes and checks the environment repository and the image registry. So the software will be packaged on image registries, and the deployments configurations and services configuration will be on the environment repository. those will be loaded from the Git from that operator, so there is no human interaction. That code that is placed on the environment repository is well tested before it becomes there, and also the images. So there is a complete, let's call like pipelines that I call there as build pipelines. So we can call it as a complete set of processes that execute over the images, the code, and the configurations, and check that everything is okay, and then is applied in the real infrastructure. And this also provides a way to deploy multiple configurations. I can show you that on the next slide, but there is another important point here that I always forget, that operator also allows to check the consistency of the state of the deployment. So the consistency means that anytime something changes on the deployment, it always tries to place it as it is described in the configuration on the repository, and also in the other direction. So if some configuration is changed, it can be automatically applied into the infrastructure. And this is a kind of provable that later Miguel will explain, way that we can kind of manage everything at the same place and assure that services are running as expected. About the environment, so as I mentioned before, using this kind of methodology also allows to merge together multiple environments here. So what this means that, as I mentioned before, we need to tackle different challenges during the test. So we have the first test that is related to software, and we try to just do a kind of unit testing and integration testing that can run outside the real infrastructure. And then we need to do the final system tests that needs to go to the real infrastructure. This kind of approach also allows to define those multiple environments and apply those changes into the different infrastructures that we have selected to run that kind of tests. And this can be all automated using also this facility, because we can just have inside the same repository different branches that can have these different describe these different environments and select these different deployments. Now another very important point. So how can we just turn everything simple for the developer in the end? So actually the developer only need to use a template. When he starts, so he imagine you have a code repository, and the only thing you need is just to load a collection of files that will collect the required configurations, will run the tools, and will register the pipelines that we need to provide the automation in the end for that code. And the other and most important point now is how can we see all together? So we run everything, we do all these kind of tasks using all the tools and everything, but how can the user, let's say, or the developer in this case, and also the operator can check what is happening and do the required validation process. So first, every pipeline will have all logs from the execution environment where it runs, and every kind of command and their logs will be sent to std out. So everything will be collected on this side, but not only that kind of logs. It is also possible to collect any other kind of information. For example, we can just summarize all generated files and everything that needs to be checked later, and place those on an artifact. Let's call it like an object that we can store here also, and associate it with a merge request. So the merge request is the most important point here. So the Git flow is about someone starting to do code, and when he just tries to start a contribution, he creates a branch. That branch can be just merged into a main branch, and that main branch, before being merged, it will be created a merge request. Over that merge request, we also collect all the history between all contributions, all changes, and all reporting and data that we can then in the end do the validation and approve that release. This means for a component, this means for all together. So now I go further into the visualization and the state that the GitOps operator can also give. So we not only have all these logs and this kind of information, we can also, this for example, for the operator, for the SysAdmins, they can also see what is happening in the system. So how the services are running, if they are running as expected, if there is any trouble. And this is something that the tools that Miguel will show afterwards also provide. So we can always check the activity, how systems are and how things are working, and do all that kind of health status analysis, and also check the application resources. So now I will pass the word to Miguel, that will just show the work that we did putting all this together.
Hello, everyone. And thank you again, Mariana, for your great presentation. So how can we bring all together? The first important step when we are designing the solution is to clearly identify the involved development and operation domains. Remembering the previous slides presented by Samuel, there should be present a mutable firewall between the developers and operators and the infrastructure. And on the first part of the cycle chart presented in this slide it is represented the phase where developers and operators do some code testing, validation, when some issue arises. This phase represents the testing, validation, and delivery domain. These actors don't act directly in other moment of this cycle, as my colleague said previously. So the resultant artifacts of this stage will be translated in a package that will be deployed on the infrastructure using tools to automate this task. And here, at this point, we are already on the deployment and analysis domain. Once the deployment step is completed, we enter on the third phase of this chart, the management and monitoring domain. Here at this level, some application and infrastructure configurations can be done, as well as its monitoring. The result of this monitoring activity will be analyzed and eventually arise a new issue. After that, developers and operators can fix their code, test it again, validate it, and deliver it again to the infrastructure. So next slide, Samuel, please. Looking in more detail at each one of these domains, and starting with testing, validation, and delivery, we are using GitLab Cloud Platform as a tool to create pipelines to automate as much as possible the procedures between issues and the code management. Looking at this diagram, Everything starts when the analysis of the previous deployment detects something that is not expected and arises a new issue. To solve this issue, the developers will do some code and start testing it. All tests are conducted over GitLab CI pipelines using the required tools defined by the developers, and the results are collected and summarized in a report. So now we enter on the validation phase right before the delivery package. Here is where a new package is delivered and is ready to be deployed on the infrastructure. Next slide. Thank you. So the validation is completed in 3 steps: tests, report validation, and merge request approval. As seen in the previous slide, after run all the defined tests through a GitLab CI pipeline, reports are generated containing the results of these tests. And this is the first step of validation phase. Then these reports are validated by the developers and operators, who will approve or not based on the results, and merge requests and approve the merge request, and then a new release is delivered. Can you go to the next one? Thank you. So now moving to the second domain, the deployment and analysis domain. Every time that a change is committed to the code repository, to the branch that corresponds to the intended environment, it is triggered a pipeline that builds the new image based on those changes, push the images to the GitLab private container registry, tagging them, and update the Kubernetes manifest files that should be located in a different code repository to split what is regarding the code development and the deployment recipes. And that's why we have here represented in this chart 2 different code repositories. Once these changes are updated on the manifest repository, Argo CD, which is the operator that my colleague mentioned before, will notice that there is an inconsistency between the new manifest files and what is currently deployed on the Kubernetes cluster. I remember that this is a pool-based deployment strategy, and for that reason, Argo CD is constantly observing the state of the current deployments and the repository code with the manifests of reference. Anytime there is some difference, Argo CD will redeploy the resources inside the Kubernetes, if configured to do so. During the deployment of resources inside Kubernetes, the Docker images are consumed directly from the GitLab's private container registry, which contains the images previously built and pushed from the CI pipeline. With this approach, and especially using a powerful tool such as Argo CD, it is possible to materialize multiple test environments. And another important topic here is regarding the deployment operation is the contention of access between to resources between projects. Can you go to the next one? Thank you. Argo CD provides some mechanisms to have multi-tenancy, allowing that different projects share the same infrastructure, preventing the unauthorized access between them. Adding that to additionally, users authenticate through the OIDC provided by GitLab, which checks the GitLab groups to which the user is mapped and ensures that the correct access to the project to the projects that the user is allowed to access to. So at this way, we are not exposing our this operator to anyone in the world with a GitLab account can access the infrastructure and do things. Another advantage of this authentication method is to avoid the creation of local users, which represents a big anti-pattern on the GitOps methodology. Can you go to the next slide, please? So the last of the three domains that I mentioned before is the management monitoring. Using a tool such as AWX, it is possible to run Ansible scripts to configure resources and manage the infrastructure. Tasks like Reback and service account management, Argo CD tenants management, and so on are easily done through a tool such as AWX or Ansible Tower. Also, this tool is very important for job submissions on HPC cluster, and it's monitoring as well. So it is also important to generate reports regarding the submitted jobs and send them back to the GitLab, associating these reports to a merge request. Can you go to the next one, please? So our next steps. The next steps regarding usability and performance testing are the test of the platform components using real use cases, identify application performance issues, and review usability improvements. For the pilot validation, we need to start gathering all reports associated to the, and associate them to the merge requests, review documentation, and finally generate a release. And from my side, it's all. Thank you for your attention.
Okay, thank you, Samuel and Miguel, for the great talk. We can now open the session for any questions that the audience may have. Please feel free to write them on the chat or to just unmute yourself and ask them directly to our speakers. Okay. We don't have any questions at the moment, so I'll start by asking a first one. So, is there any difference between a developer or an administrator regarding their tasks workflow?
Okay, I can answer that. Yes, so there is. So actually, as I show in a previous slide, but I just pick this previous slide just to try to show that difference. So the big difference here is about where they are working. Okay, so actually when they are putting their changes or applying their configurations, they are using different repositories, and that way the access and the privileges are completely split. So we have actually everyone working over Git in a central repository to manage all these services, or where also the operators can place their additional or optimizations for the infrastructure, but they will have their own code and they will manage their own code, and at the same time that will be merged in the deployment and replaced with the software that we are just loading for the BigHPC platform.
Okay, thank you for your answer, Samuel. Do we have any more questions from our audience? Okay, I can ask a second question, which is, does the provided environments must be the same for each test bed? Or no?
That is a good question, Mariana, because actually this is one of the good values that this approach brings. So the idea that we can have here is that this is not so clear. I know that is a very good question because of that. Because we are actually talking about environments. Environments are all the requirements and that software needs, right? And also we need to place those on infrastructures that are different. So actually we can have different environments running on different infrastructures, that mean test beds. And so, but the same environment can also be adapted to be on the different test beds. And this is also can be taken in place with all together on this kind of deployment approach.
Okay, thank you. Do we have any more questions from my audience? Okay. I guess the final question will be, how many reports are gathered in a GitLab merge request?
Yeah, that is a point that we are still working on. Don't know, Miguel, if you want to say something about that, but
yeah. So the idea is that we can use AWX not only for job submissions on the HPC cluster, but we can use AWX as well to monitor these jobs running. And once we get the status data and another details that we could understand as relevant, we can gather all these data and send back to the GitLab, associate to the merge request that we want through the GitLab API and so on. And this way we can centralize the information about everything that is running regarding that merge request. So AWX is the operator responsible for that task, and this could be done easily through the GitLab API and so on.
Okay, thank you, Miguel. Okay. This is the last chance to ask any questions that we may have. Okay. If we don't have more questions, I'm going to ask you to stop sharing a screen. Thank you. I'll just, sorry. Yeah. I'm going to share just our final screen. I hope you can see it. Okay.
It's easier if you have
I'm sorry, you can ask your question. Please go ahead. I don't know who asked that question, but can you please repeat it?
I think it was an unintentional unmute, not a question.
Okay. So I'd like to thank you all for participating in this session. Please stay tuned to our communication channels to know more about the next webinar. Have your message? See? Okay. Thank you for participating. The information about the next webinar will be available soon. Thank you for joining us. Thank you.